Welcome to the 5.5 video, which is use inequalities in a triangle. So we're going to learn two different theorems, and then we're going to apply those theorems. The first theorem is listed at the top. It says the smallest angle in a triangle is across from the smallest side. The largest angle is across from the largest side. So let's draw ourselves an example. Okay, so I'm going to mark this triangle A, B, C. Let's say the sides are 3, 4, and 5. So in terms of angles, the smallest angle is across from the smallest side. 3 is the smallest side, so angle C is smallest. 4 is the middle side, so that means angle A is the middle side. And then 5 is the largest, so angle B is the largest angle. And then in terms of sides, that one's a little easier in this case. The smallest side is AB because it's only 3. The second smallest side is BC because it's 4. And then the largest side is AC. Okay, so we have two examples. Example 1, 2 parts though. So it says list the sides and angles from largest to smallest. Okay, so first thing I'm going to do is mark my figure with the information that I'm given. So DE is 4.02, FD is 4.42, and EF is 4.17. Okay, so it says largest to smallest. So the largest side is DF, the middle side is EF, and then the smallest side is DE. Okay, now for the angles. The largest angle is located across from the largest side. If I go to the largest side, angle across from it is angle E. The middle side, the angle that's across from it is angle D. And then the last one that's left is angle F. Okay, take a minute, pause the video, and try the second part of example 1 on your own. When you're finished, come back and we'll go over it together. Okay, first thing that you should have done is mark the information that we are given. So angle ABC is 69.21 degrees. BCA is 39.39 degrees. And then I need to find angle A. Well, I know all the angles in a triangle add up to 180. So if I take 180 and I subtract 69.21 and I subtract 39.39, I get 71.4. So angle A is 71.4. Okay, this time let's do angles first. Largest angle is angle A, and then it goes angle B, and then angle C. Okay, the largest side is going to be the one located across from the largest angle. Angle A is the largest angle, so the side across from that is BC. Okay, then I have angle B. The side across from that is AC, and then the last one should have been AB. So hopefully we got that one right. Hopefully we knew to find angle A before moving on. If not, now you know. So let's move on to our second theorem. This is the main theorem of the section. It's called the triangle inequality theorem. It says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I add together two sides, it should be greater than the third side. So in example 2, it says, is it possible to form a triangle with side lengths of 6, 7, and 11? Okay, so what I have to do is 6 add 7. Is that greater than 11? Well, yes, this is 13 is greater than 11. Is 6 add 11 greater than 7? Yes, this is 17 is greater than 7. And then is 7 add 11 greater than 6? Yes. So you're always going to have to check 3 pairs. So any two sides added together have to be greater than the third side. Pause the video right now and try example 3 on your own, please. Okay, for example number 3, you should have gotten no. If you take 3 and add 6, it is not greater than 9. It's exactly equal to 9. It strictly has to be greater. So hopefully you got that one right. Now we have two more examples using the same theorem, but they're going to be a little different. So if we move on to page 22, we have examples 4 and 5. So example 4, a triangle has one side length of 12 and another of 8. Describe the lengths of the third side. Okay, so I have a side of 12, I have a side of 8, and then I have a side of x. I know any two sides have to be greater than the third side, or the sum of any two. So I have 12 add 8 is greater than x. I have 12 add x is greater than 8. And I have 8 add x is greater than 12. Now if I solve all of these, here I have 20 is greater than x. Here I have x is greater than negative 4. And here I have x is greater than 4. Okay, I only need two of these numbers though. There's one that I don't need. You can probably guess that I don't need the negative because I can't have a negative side. Here's the way that we're going to show that though. If I put all these numbers on a number line, okay, I'm saying x is less than 20. That's this one. So x is all this. X is greater than negative 4. So that's all of this. And then x is greater than 4. So that's all of this stuff. If I will notice, this is where all three intersect. This is where all three are present. So that tells me that the third side is between 20 and 4. It can't be equal to 4, can't be equal to 20. It has to be greater than 4 and less than 20, but it's somewhere in between there. So pause the video right now and try example 5 on your own, please. Okay, so we should have had sides of 10, 14, and x. My three inequalities are 10 add 14 is greater than x, 10 add x is greater than 14, and then 14 add x is greater than 10. When I solve, I get 24 is greater than x is greater than 4, x is greater than negative 4. Okay, I'm going to draw my number line again to figure out which of these three I want to use. Here, you should be able to tell that you're not going to use the negative, but I'm still going to check anyway. Okay, x is less than 24, that's all of this. X is greater than 4 is all of this. And then x is greater than negative 4 is all of this. As you can see, here's where all three intersect, where all three are true. So my third side is somewhere between 24 and 4. Hopefully you got that one right. If not, hopefully you see any mistakes that you made. So if we just take a quick look at our objectives, we listed sides and angles from smallest to largest or largest to smallest, just using the fact that the smallest side is located across from the smallest angle. And then we determined the possible side lengths for the third side. So that's the two examples that we just did. If you have any questions, please make sure you bring them to class, and we will be doing some examples when you come to class. Thank you. Bye.